This lesson, we shall focus on the NBT, National Benchmark Test, Mathematics or Maths. We shall look at a wide range of past exam questions and see, or past test questions, and see what to do. Okay, and see how to solve the questions and getting started. The most first section, which is section A, the first section, is on algebra and exponents, grades 10, 11, and 12. This is what this is about. So we need to simplify the expression given. So how do we simplify this? So to simplify this expression, we start from grade 10. What rule do we use here? We use what we call Bodmer's. We use what we call the Bodmer's rule. And what does Bodmer's have to do with this? So we deal with brackets of division, multiplication, addition, and subtraction. So now, in other words, before we can do addition and subtraction, we can first perform division and multiplication. So in other words, we have 1 plus 2, and we divide that by 3, all over divided by 2 out of 3 minus 1/4. What is this? Right, so we need to first perform the division. So what we then do is we can do 1 plus. So the 2 divided by 3, we can write it as 2 out of 3 like this. And you divide everything by 2 out of 3 minus that. Now, the best way to do this is to multiply by what you call the LCD, the lowest common denominator. What is the lowest common denominator? 12. 12 out of 12. Okay, because 3 by 4 is 12. Right, and the 12 out of 12 is 1. So we have 12 by 1 giving us 12 plus 12 divided by 3 is what? It's a 4 by 2. Now we have 12 divided by 3 giving us a 4 by 2 minus 12. Divide 12 by 4. You get a 3. And this gives us exactly 12 plus 4 by 2 is exactly 8. 2 by 4 is 8 minus 3. What is 12 plus 8? It gives us exactly 20 out of now 8 minus 3 gives us exactly a 5. And the result becomes a 4. And hence the correct option is A. Any question, remark, or comment here? No. Anything to add or remove?
No, thank you. So
Nothing. Yes.
for this, you have to start with the division first.
You have to start with the division. Correct. You need to start with the division. In particular, see, the way they wrote it here is just like in the same line. It is tempting for students to perform to say 1 plus 2. Okay, because some students can do that. And obviously that is going to become a huge mistake because you must first begin with the division. And now
Okay.
the students are tempted to think there's 1 plus 2. And then now if they see 1 plus 2, they'll be like, okay, it's 3. But we can't perform this addition by Bodmer's because Bodmer says first deal with brackets, first do division and multiplication, and then you can do addition or subtraction. You know? All right, so that was a little trick here. Okay, we move to the next point. Right, we move to the next point. The next point is this one, number 2. Find the value of R in the sequence, some of which we're going to be together. Okay, find the value of R. We have that the first number is 8, 5, 3, 2, 1, 1, 0, 1, minus 1, 2, Q, R. What is this? What is the difference here, for example? Okay, is there anything that is there any difference? Is there any ratio that is common here? For example, if you look at this, it is 8, 5, 3, etc., etc. So now, what is happening here? What kind of a sequence do you think this is now? Is it arithmetic? Is it geometric? Is it neither of those? But what kind of a sequence of is it mixed? Okay, right.
It looks mixed.
Okay. All right, because from 8 to 5, there's a reduction by 3, right? Because 8 minus 3 is 5. But now if you then say you're looking at differences, or you do the difference even saying 5 minus 8, right? 5 minus 8 would give us exactly -3. But now here the difference becomes 3 minus 5 becomes a -2. Right. So, and obviously it's able to show us that. Okay, there are a couple of things you can do, but you can really see that if you perform the division, it doesn't actually yield any ratio. We can just obviously perform several divisions. Like if you say 5 minus 8, you get a minus 3. 3 minus 5, what do you get? You get a minus 2. And 2 minus 3, a minus 1. 2 1 minus 2 is a minus 1, and this gives us a 0, and this gives us a minus 1, and this gives us a 1, and this gives us a minus 2, and this gives us a 3, and so on. Okay, let's just check if there is anything common here. So if you subtract these two, this and that, what do you get? Right, you get minus 2 minus into minus 3, and that will give us a 1. And here, this together with this, what do they actually give us? 2 minus this, right, is minus 1 minus this, would give us exactly what? Would give us a 1. Okay, and if you subtract these two, you get exactly a 0. And obviously, that determines the fact that it is just not actually quadratic. So now, because it is not quadratic, what would you suggest this particular sequence is in this particular case? Because you need to determine the value of R. Right, so it is not quadratic, for example. So, I mean, we are testing here, right? So you can see that it is not quadratic. What kind of a sequence do you think this is, Noah? Because I want interaction.
Maybe it's
It's not quadratic.
arithmetic,
Okay. Because if it is
arithmetic
okay,
mixed with
that's yes.
geometric.
Yeah, okay. But you can see that the entire sequence, if you perform, we can see that it is not arithmetic, but thanks for obviously the input. Right, you can see that it is not arithmetic if you consider it that way. Right, you can see that it is not certainly arithmetic. But also it is not geometric. It's not geometric. Because if it were geometric, you would have, for instance, T2 over T1 would be 5 out of 8. And T3 over T2 is actually 3 out of 5. And obviously, you can see that it is not certainly that. So, right. So now the question is, what kind of a sequence is this? And that is what you need to think about as you're looking at this particular sequence. Let's look at the first one. The first one is a multiple of 2. Okay, it's a power of 2, in which case, therefore, we can see there's 2 to the power 3. Right, and then you have the 5, you have the 3, and then you have 2, like that. And then what you see, and then you can see a 1 and a 1. Right, so what does this actually then suggest to us? Because if you have actually the 8, after 8, you actually attain a 5. And you can see, therefore, that at this point, the 5 and the 8 do not give an arithmetic or geometric. So what would one do in a situation like this, Neo? Right, so obviously, I mean, you need to look at this and think very, very carefully. But also, what would one say? Because it is not arithmetic, but also it is not geometric. Simultaneously, you can see that it is not quadratic. So the question is, what would one do here at this point? Right, so obviously, I mean, you need to think. Right, so what would one do? Is it mixed, for example? That would be the question. Is it mixed? Right, it's a mixed sequence. Okay, right. So, I mean, you need to look at this and reason and think about this. But also, the way it has been done is the fact that it has just been, you need to, because what is the question? The question is saying, find the value of R in the sequence. And now, if you look at this sequence, then what would we get if we actually look at this? Because there's an 8, there's a 5, and the 5 itself is an odd number, right? And if you look at the fact that if you start this from the end, right, and you're looking at it from -1, 1, 0, 1, 1, 2, 3. Okay, what do you see about the 3 and the 2? Okay, the 3 and the 2, we can see that indeed their sum gives what? Their sum gives 8. And, or rather, their sum gives 5. The 3 and the 2, yes.
3. Oh, yeah.
Yes. Okay, the sum of the 3 and the 2, for instance, would give 5. And the sum of the 8 and the 5 would give what, for example? Would give a 13. Right. And the sum of the 1 and the 1 and the 1 would give what? Would give a 2. Right. And the sum of this and that would give what, for example, of 0 and 1? Would give a 1. Right. And so what would these actually try to tell us? Okay, let's look at this. There are a couple of ways to investigate this. So you have 5. You have 8, excuse. Right. And now, if you look very carefully, if you add the 5 and the 3, what do you get? The 5 and the 3 would give 8. Well done. So you can see 5 and 3, they together give what? 8 as a sum. And then now you have the 3 and the 2. What do they give? They give exactly a 5. So they give us the preceding term. Okay, and the 5 and the 3, they give us 8. Okay, we're investigating here because we're just doing this question. I've not even done this question. I've never done this question before, but I know that there is surely a pattern that exists. Right, so you have the 3 and the 2. Now you have the 1 and the 1. Okay, let's check this one. Now, if you look at the 2 and the 1, if you add them up, they give what? They give 3, which is a number we had there. Right, so we actually have been able to sort of uncover a pattern here. And let us actually sort of, economize on that and capitalize on it and be in a position to do the following. Right, so, and that is the answer to the question. Right, so you need to look at this a little bit more. And obviously think a little bit outside the box and see, and we've already got the answer. With this approach, it appears that we can be able to get subsequent numbers because their sum must be the preceding term. So that is the little trick. Right, I'm going to write 8, 5. I'm going to write 3. I'm going to write 2. I'm going to write 1, 1, 0. Okay, 1 minus 1, 2, Q, and R. Okay, now let's start. We said you add these 2, you get 8, which is there. You add 3 and 2, you get a 5, which is what we had. We add 2 and 1, we get a 3, which is what we had. We add 1 and 1, we get a 2, which is what we had. We add 1 and 0, we get a 1, which is what we had. Right, because we saw that differences are not working. So we're looking at sums now. Right, you add 0 and 1, and you get a 1. Okay. Right, you add 0 and 1, you get a 1. Okay, that's very interesting though. But you add 1 and minus 1, you get a 0, which is what we had. Right, so we add these 2, what you get? You add these 2, you get a 1. And now the 1 appears to be further away. Now, what kind of a pattern then is this? Because I want us to look at this very carefully. So if you add the 3 and the 2, you get a 5, and the 5 is actually exactly what we have there. You add, but you can really see the displacement that this is sort of building up. So you add the 2 and the 1, you get a 3, which is immediately preceding those. Right, you add the 1 and the 1, you get a 2, which is actually preceding those. But now you come to this point, when you add 1 and 0, you get a 1, which indeed is preceding those, is preceding the numbers you sort of added together. And you add 0 and 1, you get a 1, which is immediately preceding those. You add these two, you get a 0, which is immediately preceding those. You add these two, you get that, which is immediately preceding those. So yeah, we're good. So now the question is, okay, they want to find us. So you can be able to do that. Because when you add this and that, what would you expect to get? So in other words, when you add 2 and Q, you must get what? You must get -1. Right. When you add 2 and Q, you must get -1, because if you add this and that, you get 0, which is that. So when add 2 and Q, 2 plus Q would give you -1, so that at this point, what is Q here? Q is -1 minus 2, yeah, like that. You need to be very fast and you get -3. So we're getting that Q must be -3. And then now, if you get -3, you add this together with that. What does it yield? Okay, we're done with the question. Right, because when you add Q and a Q, you get Q and you add Q and R. Right, when you add Q and R, you would have to get, okay, but Q already know. Yeah, it's -3. You can do that. Well done. So you already know the Q. Q is -3. So you add -3 and R, you must get a 2. So what is this? So -3 plus R is 2, which means R is what? R is 5. And calculate, they say find the value of R, and you can be able to see that the answer is 5 there. Okay, yeah, any question, but a very interesting. But yeah, what we saw here in this one, we tried the differences, they couldn't work. We tried the quotients through the geometric pattern, they could not work. We tried quadratic, it could not work. And obviously, this is most like grade 10 work. Because it's grade 10 work, I did not expect quadratic to be part of grade 10 work, because of the fact that this is classified as section A. And we are able to see that at this point, section A is, oh yeah, obviously section A, but it's basics. But yeah, these things anyway start from grades 10, 11, and 12, in which case there's a potential to actually have some things from the other grades as well. So yeah, in other words, you really can have a mixture of the 3 grades, 10, 11, 12. Yeah, but any question on this one, Neo?
No.
No question. We'll move to the next one.
Yes. But yeah, this question was interesting.
It was quite interesting because, yeah, the student will be like, okay, is it arithmetic? It is not. Because arithmetic, you say 2, 2 minus 2, 1, 2, 3 minus 2, 2, and then you see it's not. And then it's a geometric. You see it's not. And then what you do? Okay, some students would give up. Okay, we tried sums and sums worked. Okay, we'll look at the next question. Right, number 3, evaluate the following. Okay, let's look at this one. Evaluate the following. So to evaluate this one, you obviously need to think. What do we do? What is the first thing to do? Right, we have 2 to the power 1001, 2 to the power 1000, 2 times 2 to the power 999, like that. Okay, now to deal with this, we need to look at the answers. It's just a simplification of this. So we need to sort of attempt to simplify these, and there are a couple of ways to do this. But one easy way to do this is what? Okay, there are tons and tons of ways that exist to simplify these. But you can see that the power here is 2000 and what? It's 2001. And the power here is rather is 1001. Here is 1002. So now you can leave this 1001. It doesn't really matter what you do in a sense, you know, you can leave this one, this 1001, and then come to this, and come to this now, and then say, okay, this one you can deal with it because it is actually 2 to the power 1000, and this one to the power 1. So you can add the exponents, meaning you have 999. When the bases are the same, you add the exponents, grade 10 exponents, which means 2 to the power 1001, 2 to the power 1000, and 2 to the power 1000. Oh, we're good. That was the little trick. And we're done. We're done. Because these two add up. These two most certainly add up because these are like terms. And we have 2 to the power 1001 and 2 to the power. So these are like two things that are the same. Like terms this. Right, so we can pull out the highest common factor. What would the highest, okay, because this is 2001 here, minus, right, and this is 2 to the power 1001 if you multiply this. So what is the answer? The answer is 0. So, and the correct option, therefore, is option A. Right, so
Oh,
yes, very, very interesting though. Right, so any question on these? No.
no, thank you.
No thanks. Okay, good. Just some exponents from grade 10, so you need to remember the laws of exponents there. Okay, now find an expression for R in the following. Okay, it's grade 10 work. This one is strictly, meaning you need to make R the subject. How do we make R the subject? Which is S minus 2 divided by T, which is 1 over P plus 1 over R. Find R. Okay, to find R, what we do, we can perform algebraic manipulations and write S minus 2, divide everything by T, and then write 1 minus P equals this. And what is all this? Right, so with all this, you can write S minus 2 divided by T, 1 minus that, equal 1 over R. TP, you divide this one by T, you get a P. PS minus 2. Okay, P cancels, giving us a T. Right, and you have 1 minus R, like this. And therefore, R is the same as what? R is the same as TP. You like invert this. So it's TP all divided by, this is what you have. So you have PS minus 2P minus T. Okay, P times S is PS minus 2P minus T. And this one is exactly that option there. TP over PS minus 2P minus T. So that is the correct answer. Right. Any question on this now? Or anything to add, remove, or subtract? Right. Any idea?
So, is this
Yeah.
the same equation from this one?
Yes, it's just the same equation because they said to find an expression for R. Find it. So in other words, just make R the subject of the equation. Like
Also,
solve for
you look
R.
for the LCD
Yes,
first.
you look for the LCD first. You look for the LCD
Okay.
first. Yeah, making sure that you isolate. You do term isolation and term collection. So because you need to make R the subject first, the first thing first, because if you're supposed to make R the subject, you need to check and look. Where does R appear? In how many places does it appear? You know, because there's no R here. Okay, this one is it's a term that there's no R. This one here has no R. So the terms that have no R, we can group them and take the term
Oh,
that is
okay.
R and like isolate it so that in the end we're able to make R the subject. Because one thing is, yeah, we can mix the terms up, but now we need to realize, okay, let the terms without R, we put them together. No R, no R, put these together. And then we have 1 over R, we're good. And then now we have 1 over R, a term that is R, which is what we want, one expression for R. So we then say, okay, yeah, in a term that is R in it is it's this one here, and then we just make R the subject, you know. So that is sort of what happens here. Right, right. So we good. Yeah. So yeah. Any question on this so far? Okay,
Nope,
think
it
about it.
makes sense.
Think about it. Yeah, and see what you need to do here, and see what you need to do. A bit of Okay, we'll move to the next question. Let's check the next question. See what to do. Right. Okay, now we're looking at question 4. Now we're looking at question 5. All right, now find the square root of x all to the power 6. The square root of x all to the power 6. Because we have that x is 4 times the cube root of 25. Okay, so but we need to find this. Okay, very often we need to simplify things, but here we need to like complicate things. Right, we need to complicate things, sir. And to complicate things, we then proceed as follows. Right, we actually continue as follows to sort of attempt to complicate things. What do we do here now? What do you suggest we do here? Please think about it.
It's
1 minute. Yeah.
x
What do we do first?
4 times
Hello?
25 to the power of 1 over 3.
Yes, how are you? Yes. Yes. Yeah, excellent. Is it possible that you give me a call at 12:30? or I can give you a call back at 12:30.
That's perfect.
Yeah, I'm just having a discussion now with some students. So yeah, 12:30 is the best time, then we can talk more. Okay. Okay, thanks, Dan. Okay, goodbye.
Yeah.
Thanks, goodbye. Right. Greetings, Noel. Okay, we're having this now. And we're saying find this here if X is this. Right. What did you suggest we do there? I was speaking to somebody else.
4
Which-
times 3.
Yeah, 4 times, yeah,
Mhm.
4 times that.
Sorry, 4
Okay.
times 25.
Yes. Yes, yeah,
to
like
the
yeah.
power,
Oh, yes. Okay, you can write 4 times 25 to the power 1/3. Correct. Because this is like the cube root. So it's like 1/3, like that.
Yes.
And then, yeah, what do we do next? Because there's a square root there. One thing you can do is to take the square root of this or raise it to the power. Okay, then we have 25 here to the power 1/3, like that. And then this becomes the square root of x. And then you can take the square root of 4 times the square root of 25.
Wait, why is there square root by x?
Okay, yeah, why is there square root by x? Because in the end, the examiner said we need to find the square root of x all to the power 6. If we've been told that x is 4 times the cube root of 25. So obviously we need to,
Okay.
yes, we need to put the square root on the x, because they're saying if x is this, then we need to put the square root and raise everything to the power 6. It appears that it is the case, right? Okay, so in the end, then we take the square root of the x, and then we raise everything to the 6th power. Right, and then it becomes what? Right, so it becomes, therefore, what do we then are we able to achieve? Okay, so yeah. We have, what is square root of 4? What is the square root? Square root of 4 is 2. The square root of 25 is what?
5.
Right, the square root of 25 is exactly 5. Okay, so you have a 5 to the power 1/3, like that. Okay, we're good.
Okay.
Now we've just put the square root on the x because we need to put the square root and raise everything to the 6th power. Okay, now we continue then because we have put the square root of x, the square root on the x, and then we have the square root of x. We need to put the square root, and then now we must raise it to the what? To the 6th power. So if we do it on the left, we must do it on the right. So we have the right and raise everything to the 6th power, like so. Getting the square root of x raised up to the 6th power, with 2 to the 6th power, with 5 1/3 by 6, which means the square root of x to the 6th power. What is 2 to the 6th power? 5 to the 2nd power. Okay, because if you divide 6 by 3, you get a 2, and therefore, which means square root of x to the 6th power. What is 2 to the 6 times 5 squared? Okay. It's interesting this. What would that be? What would that be? What is the best way to do this? Okay, remember you have no calculator in this exam. So you can do like 2 squared, 5 squared. You can do 2 squared, 5 squared, and then 2 to the 4th power. Doesn't matter. I mean, you can do it your way. Right, so, but if you have, which is 2 by 5, to the 2nd power, 2 to the 4th power, what is 2 by 5? 10 squared. 2 to the 4th power, it's 16. I mean, I know there are too many ways you can go back. You can do primary school multiplication here. All right, but like 2 by 5, it's 10. Then you have 10 squared. 2 to the 4th power, it's 16. Right, now 10 squared is 100. 100 times 16 is like 1600. So which is the option? It appears it is option C. Anything to add, remove, or change here now? Right, so
No, thank you.
okay, good. But it was a question of really complicating things and putting a square root on the x and raising everything to the 6th power to actually be in a position to obtain the answers. That is what this is about. Yes.
So what you do on the left, you do on the right.
What you do on the left, you do on the right. Well done. What you do on the left, you do on the right. So from time to time, I'm going to give you a chance to share what you think, because, you know, it's very important. And these questions are from you. And so, yeah, they're for
Okay.
you. And yeah, okay, they're for the student. Okay, so the student must participate a little bit. Let's look at Renata. Renata drives to work at an average speed of y kilometers per hour. So the examiner gives us what we call the average speed. Y kilometers per hour is the average speed. And she drives the same route. Okay, she drives the same route home at an average speed of x kilometers per hour. So now Renata drives to work. So here it is to work. But now there is another average. There's another average speed by Renata, and the average speed is also what? X kilometers per hour, but you also have Y kilometers per hour. So it's X kilometers per hour home. All right. So, right when drive the same route home at an average speed of this, when it's getting home and it's traveling at X, but when it's going to work, it's traveling at the speed Y, which is average speeds here. Find an expression for the average speed of her total trip. Find an expression of the average trip, of the average speed for the overall trip. What do you do here? What do you think we do here? Now, I know you can have very, very clever ways to do this one. What would we do? Okay, because you're given two speeds. When you're going to work, you travel at the speed y. Average speed y. But you need to go back to grade 10 and say, okay, I'm going to give you a chance because I know this one can be done in like 1 million ways. And right, so speed equals distance over time. Speed equals distance over time. So in other words, what do we know here? In each of these cases, it's going to travel at the same distance. Or it's going to travel rather the same distance, because when you're going to work and you use the same route, surely it's the same distance when you're going to work and it's the same distance coming back home. But what is different here? The times are different. So there's time 1 and there's time 2. Time 1 is when going to work, and time 2 is when going back home. What do we want? What do we want to do? We want to find the average speed for her total trip. So what is the formula for this? So now, what is average speed? Okay, from grade 10. Average speed becomes total distance. Okay, so average speed is total distance divided by total time. That is what the total distance divided by total time. So yeah, we are looking at this. Remember that now we are interested in the total distance. What is the total distance? So we need to check and say y for the first one. Average speed equals distance over time. So it's distance over time 1. And then now we can be able to find the total distance. What is the total distance? Or rather the distance here. The distance here is y time 1. Right, you can do it like that. And then also, I mean, there are many ways to do it, but and then now you come and then say, okay, now when this is when going to work, traveling at an average speed y. Now it's traveling. I know that somebody can be like, okay, but this can be done in 2 steps, right? When traveling back home, it's going to travel at this speed because the formula is that speed equals distance over time, right? So in other words, at this point, you will then say the speed is x, the distance is the same distance because it's the same route, and the time is there, like so. Okay, now we make D the subject. So we solve for D so that we have xt2. We have xt2. We cross multiply getting xt2. In other words, at this point, we then say, okay, right now, we're happy because we have the distance here. So now, what is average speed? Average speed is total distance over total time. It means that now, what is the total distance? The total distance is going to be, it's first going to cover this distance. what distance is actually this person gonna cover here, right? So it's gonna be in a position to cover this particular distance here when going to work, but it's also gonna cover the distance when traveling back home. And that distance is y_t1 and x_t2 divided by the total time t1 together with t2. This is the total time t1 together with t2, like that. Right, so now what then do we actually have to say here? Because if the total distance, but now this total distance is the same, right? So if this total distance is the same, what do we then do? But also the two times that are being traveled here are what? Right, so if these total distances are, the total distance is the same, what would these actually tell us? Okay, it's traveling the same distance, but we agree that the speeds are necessarily different. But what would this be? In other words, we are saying here the distance is the same. So which means that you would have that y_t1 is the same distance, but also x_t2, it's still the same distance. So if these two variables are the same, we argue that the two speeds are essentially different. The two speeds, x and y, are different. So what would you say about the two times? Right, so obviously even the two times will actually be very different, but we shall have an equation that says y_t1 is equal to x_t2, meaning that we can do more. We can be in a position to manipulate these algebraically because the distances are the same, which means therefore y_t1 equals x_t2. And if that is the case, we are at liberty to do more. And we can be able to make t1 the subject or t2 the subject. Right, so which means that we can say t1 is x_t2 divided by t1. All right, so we look at this carefully. So we have this here. Right, we have this. So we have y_t1 equals x_t2, which means that you have t1 equals x_t2 divided by t1. Okay, we have this equation, so we solved it. So now we come to this because we just have at our own time, so we've put the t1 to 2. The examiner did not tell us of that one. But you come to this one here and you perform the substitution. So if you perform substitution, what do? You come here and in the bottom, you put x_t2 over t1, right, x_t2 over t1 plus t2. Okay, it doesn't matter what you do, but you want to simplify this whole thing so that you can get an answer that corresponds to what the examiner got. And now you have y_t1. So y_t1, we've already said y_t1 is actually the same as x_t2. So you can put any of those, meaning that wherever you have y_t1, you can put x_t2 and vice versa. Right, so look at your equations and see which one has any of it. Doesn't really matter. So wherever there is y_t1, for instance, you can keep y_t1, right? If you keep y_t1 and then say there's x_t2, but x_t2 is y_t1, like this. Right, so what is this? What is all this here? Okay, we spoiled for choice. Let's manipulate this. Doesn't really matter. So I know you can do this in the least amount of time. So you can put it's 2t1. It's 2t1 because we have y_t1. Doesn't really matter. As I said, there are too many ways to do this question. And you can also have a different expression here. So you have 2y_t1. And when you get to this point, you have replaced let me see what we did here. Let me see what you did here. Okay, look, here it must be what? All right. It must be a y. You divide it by y here. You divide it by y because there's y_t1 equals x_t2 divided by y, getting t1 equals x_t2 over y. So that gives us t1. So you're gonna be in a position to come here and then say, wherever there is t1, okay, just write clearly here, Wherever there is T1, you can put this guy, right? Meaning in wherever there is T1, you can put X T2 over Y, like this, plus T2, like so. Right. So we sorted. Right. So yeah, there's too many ways to do that. But yeah, I'm just thinking now because this one is X and Y in it. Okay, there's X and Y in it, and also it doesn't really matter. Okay, that's yeah. Okay, you can also keep the X and Y here. Doesn't matter what you do, but this is going to be the same in the end. So you have X to 2, and you're trying to simplify this. So now in the denominator, okay, there's only this Y there. So you have Y to 1, X to 2. You divide everything by Y, because this one here is X to 2 over Y plus T2. Okay. Right. Okay, let's look at the denominator of this. Okay, if you multiply it through by the Y, you're going to have X to 2 plus Y to 2. Okay, yeah, and then here you have, for instance, a Y squared T1 plus X T2. Okay. So what is all this here? What is exactly all these, and what are we actually getting actually at the end of this? Okay, let us simplify here. We can be in a position to see what to do. If there's anything to get rid of here, we need to get rid of the times. We need to get rid of the times, right? So let us get rid of the times. What do we do to get rid of the times? So once you get to this point, in the denominator, we can factor out something. In the denominator, we can factor out something. So in the denominator, we can factor out, for instance, a T2 and have X plus Y, right? And then pull out a T2 there. And in the numerator, what are we able to achieve? Okay, obviously the T1 and T2, but we can use any of the equations we have. Wherever there is T1, you can put this one. Yes, right. So we are moving from this one. That is, for instance, a Y squared. And there's a T1. What is the T1? The T1 is X T2 over Y plus X T2. Okay, yeah, we're done. So in the end, what is all this? This Y is going to cancel a single Y there. And this is going to give us exactly Y T2 X T2 divided by X plus the Y T2. Like that. So what then are we able to achieve at this point? Okay, there's an X. There's an X here. There's an X, right? So the Y cancels, but there's an XT. Yeah, so there's an X there. So that in the end, what then are we able to achieve? Let us simplify. Let us put everything here and see what we're able to achieve here as a simplified answer. As a simplified answer, let's check what we can get. Right, let's see what you can get of this. Yeah, you know, there's a more direct way to actually do this because you have the average speeds that are 2 of them, so you can be in a position to do this with ease. So now we said with xy t2 x t2 divided by x plus y t2. Right, so if you have x t2, and then now you would have y plus 1 divided by x plus y t2. What is all this here? So t2 will sort of cancel. And if it cancels out, you can have an x together with a y plus 1 over x plus y. All right, now check this out and see what one can do to simplify this exactly, or if there's a missing variable. Right, you need to check this out and see if there's a missing variable anywhere here. Right, if there's a missing variable. Right. Let us take this, check this carefully. What would this give us? Okay, so what I want to say at this point is that in a nutshell, the result we're expecting here either way is that there are two average speeds in different directions. So the average speed would be the sum of the two speeds divided by 2. So whatever we're expecting here, I need to check this very, very carefully, but the average speed must be as follows. Right, so we must have that the average speed must be the same as what? The average speed must be x plus y divided by 2, either way. Meaning, I'm expecting the correct answer to be option D. Right, I'm expecting the correct answer to be option D. So I'm going to say, take note of that, that whatever we do here, it must simplify to that. So yeah, that is what needs to happen. So one needs to check out the working here, but yeah, it must work out to that exactly. So need to check out the working, but in the end, then if you have two different speeds in different directions, the average speed for the total trip must be exactly x plus y divided by 2. So in other words, because what happens here is this person travels home at a speed, travels to work, right, from home to work at a speed y, kilometers per hour, and travels back home at a speed x. Right, so you're traveling from work to the house or home, right? So if this happens in kilometers per hour, right, and therefore the average speed would have to be the sum of the x and y divided by 2. That's what needs to happen in general. So it must work out to this either way. But obviously, as I said, that would be one way to sort of be in a position to prove that, right? I'm interested in really saying that this can be achieved through the fact that from grade 10, I wanted to demonstrate this in detail. From grade 10, speed equals distance over time. Okay, so we can be able to use this formula from grade 10 to get that. Because if you then say that speed equals distance over time, and then you then say, what is the speed? The speed, for instance, is, I want to do this a bit more in detail than just to be this short. You then say the speed is y, the distance is the same because it's the same route over the time. Because now if the speed is, if you're slower, then you take more time. So in the end, then we have that the times are different, because if you're slow, you take more time, but if it's faster, it's going to take a shorter period of time, right? So I'm expecting this to be the result. So now you then say x would be the same distance over a different time, right? So now, I mean, this must work out beautifully because the times are different, and therefore the actual speeds are different. Right, so I want to make sure that I put a bit more detail to this, right? So that in the end, then if you have these two equations must be used to get to this point. So how can you use these two distances to get this point? So there are several ways of us to do this, but I want to be more general in my review. Let's spend a bit more time on this one. Right, so, but what do we then say? You would then say average speed, as we said, right, average speed is going to be total distance over total time. Right, I'm trying to put some details to this. So you'd say average speed is total distance. Okay. So the total distance. Okay, so now you say total distance divided by total time. So one thing you can do is to say the total distance, because they move distance z, so you can call the total distance d, and then the total time t1, t2. You can do it like that, right? So that in the end, then you then say Okay, what is the total distance? The total distance is like 2d. And over the total time is going to be exactly T1 and T2. So that in the end, then you come and then you say, I'm trying to actually do this in a more general way. So that in the end, then you then say, what is time 1 times 2? So you add up the times, but what are the 2 times? Right, so you can do 2d over, what is time 1? Right, time 1, you can get it from this. If you make time 1 the subject, what do you get? You get d over y plus, and you come here, time 2, d over x. We're good. Okay. Right, so it works out wonderfully. Just check what you're getting. So you're getting the total distance. So in the end, then you'll be able to see what you're getting here. So what are we able to achieve out of this? Yeah, because the total times would be exactly what you get. So it's going to be time 1, time 2, and you get, when you make time 1 the subject, it's d over y, d over x. Okay, right. So now you can factor out d out of this. So you have twice d divided by, okay, this is very interesting. So you have d over y, d over x, and you multiply these by xy, and also you multiply these by xy. Okay, we're good. We're good. We're good. Right. All right. Yeah, the x cancels. Y cancels getting xd. Okay, yeah. XD, YD. Okay, if you multiply these, the X cancels giving us a Y. The D, so you can get 2xy divided by x plus y. In particular, that has to be sort of the result. That has to be the result. Okay, check this out. So this would have to be, therefore, the correct answer to this particular question. So the correct answer will have to be B. Any question? What do you think here now? Total distance is going to be, obviously, you travel home at distance d. You travel to work from home, and you travel from work back home. You travel the same distance, but here you travel at x kilometers per hour. You travel this one yeah, that is y kilometers per hour, x kilometers per hour, and now the average speed becomes the total distance. So total distance is you travel a distance d. Well, the distance is the same. So if we want to find the total distance, you can just say 2 times some distance d, and divided by the total time, you're going to take time 1, time 2. And then now it's total distance. And then what is time 1? Right, you can deal with the time 1 and then say, what is time 1 out of this? It's going to be d over y here. What is time 2? It's going to be d over x. An interesting question. Then you need to just simplify this, because this is going to cancel out either way. You factor it out. I mean, one way to do this would be to say you factor it out from both the numerator and the denominator. So you would then say you have twice d, you divide, take d out, you have 1 over y, 1 over x. And then this d cancels out, giving us 2 divided by that. Okay, so 2 divided by 1 over y, 1 over x. 1 over y, 1 over x. And then we have xy, xy. And then now this is 2xy, and then this x cancels, y cancels here, giving us x, and x cancels, giving us a y. So yeah, for this particular expression, the correct answer will have to be 2xy over x plus y. So yeah, any question now? Yeah, but a very interesting,
So
yeah, a very
I have a
interesting
question.
analysis. Yeah, okay. What do you think?
So you have to find the LCD first.
We have to find the LCD. Good. Yeah, we have to find the LCD because you
That's how you got 2xy. That's how you got xd plus yd.
yes, that's how we got actually XD plus YD. The LCD.
Oh,
So you can
okay.
always do the LCD here. Yeah. In particular, yeah, I mean, yeah, you can even do the LCD way. In other words, you can have XY here, you know, etc. etc. And you'll get to this. Anyway, yeah, too
Okay.
many ways to look at. Yeah. What do you think? What do you suggest is another way to do it? Any other method? Because I know that it can be
No.
too many ways. Yeah.
No.
All right, we move on to the next one.
Um,
So, yes, you have a take. No, no take, nothing.
no.
Okay, let's move to the next
No.
one. Okay, so don't waste time. Two integers have what? Have a sum of m. Two integers have a sum of m and a product of n. What do we do?
So for sum, you're gonna say m
Yes.
plus m,
Yeah.
and then
Okay, for
maybe
sum,
you're
yes.
gonna say m plus m
Yes.
multiplied by n.
Yes. And then what are we
Okay.
supposed to do? What are we supposed to do? You're right. You're right. Find an expression
And
for the
then
for
maybe you're
the
gonna
sum of the squares of the two integers. Okay, so now obviously because there are two integers that have the sum n, so you can let x and y be the integers. Let x and y be the integers because there are two integers with the sum m. So if you add them up, x plus y, you get m. But now that is the sum. So these are the two integers, but their sum is m. But also, and their product is what? Is n. So it means that when you multiply them, you get n. Now find an expression for the sum of the integers. So for the sum of the squares, sum of the squares. So in other words, now you need to find the sum of the squares. Okay. So in other words, you need to find x squared plus y squared. What is this? You know, that's what we need to do. So what can we achieve here? What are we able to achieve here?
m
Okay,
squared.
no. Okay.
M,
Okay, yeah, there are little tricks. There are little tricks. Okay, never mind.
mm,
We need to solve for x. These are like simultaneous equations. Okay, yeah, we need to solve like for x and y and get the answer. So how do you solve for x and y? There are too many ways to solve for x and y. Like, let's make x a subject here. We have m minus y, call it the first equation. And then, yeah, call this one the second equation. And then say put one equation into the other. You know, we need to get okay, we got x, but here's multiple equations. We need to solve for x and y. Right, but now having made x a subject, then we need to substitute into the other equation so that we can actually be in a position to get the y. Okay, that's what we do. So now x is this, so in the place of x, you put m minus y, and then there's y. Okay, because in the place of x, you've put m minus y, and then there's y equals n. What do we then achieve here? What can we then achieve here? We need to get, make y the subject. You need to solve for y. So this is quadratic, meaning it's my minus y squared minus n equals 0. Y squared. Move this one to the other side. Y squared. Y squared minus my. Y squared minus my plus n equals 0. Y squared minus my plus n equals 0. Okay, so what then can we be able to achieve out of this?
factorizing.
We can factorize, right? That's one thing you can do. Because you need to find
Also,
an expression for the sum of the squares. Right, so we need to find an expression. So we need to find x squared plus y squared. Yeah, what do you think now?
make y the subject, I think.
Yes, we should make y the subject. Right? Okay, there are too many ways, yeah, but you can come up with a nicer way to do it. Okay.
Y squared.
Yes.
Y squared equals my minus n.
Y squared is my minus n, yeah?
And then y is square root my minus n.
Yeah, yes, I get your point. Okay, yeah, there are too many ways to kill a cat. There are too many ways to kill a cat. Okay, this would be very interesting, but yeah, you're right. But this is quadratic, so you need to use the quadratic formula because we want to solve for y. So we just need to use the quadratic formula because we can't easily factorize this. You know, we can't really factorize this by inspection. You know, we need to use the quadratic formula. And then obviously, then after we use the quadratic formula, then you can be able to, because you need to find an expression for the sum of squares of the two integers. So when we have x is equal to m minus y, what do we have here? Okay, so what do we have here? Okay, we need to get the value of y from this. And we need to get the value of x. Okay, right. So yeah, there are two many ways to do it. Okay, x is m minus y. If there's x, you put m minus y, then there's y equals n, and then there's my minus y squared minus n equals 0, which means you have exactly y squared minus my plus n equals 0. Y is minus b plus or minus the square root, because we're not told about the integers whether they are negative or positive. 4ac divided by what? Divided by 2a, which means that you have minus b, which is m plus or minus the square root of, right? The b squared is going to be like m squared minus 4. A is 1, c is n over 2a. Okay, a is 1 in this particular equation. So this gives us sort of the numerical value of the y. The numerical value of the y. Right, so now, what is this? Okay, we need to get the x as well. So what is the x? Right, so to get the value of the x, you need to then say, right, you need to then say, okay, yeah, just obviously just working this out. Okay, right, but very interesting though. Okay, so yeah, you got the y. These are like the possible values of y, but you know that if you get the possible values of y, you can use any of the equations. Like the product is n. So now you can be able to get x here. What is x here? So you know, therefore, that x is that. Yeah, but it's not very nice. But you can use the sum x plus y equals m. Okay, you're spoiled for choice. The sum is m and the product is n, so you can use any of these. But the product is not very nice. Products are gonna, because if you get, okay, we're gonna be able to get these any of the correct answer here. But I mean, you know, you're gonna work hard with the fractions, so we need to. The sum is easier. So yeah, we got y, then we need to get x. X is minus y plus m, for example. Okay, that is the value of x. So now we have minus y, which is minus this. Okay. All right. Okay. Okay, now you can multiply everything here. So you can get minus m, you multiply by the negative, it's still going to be plus or minus. Or you can write minus or plus, because you multiply negative by positive, you get a negative, and then a negative by negative is a plus, so but it's going to still be plus or minus. M squared minus 4n over 2 plus m minus m plus or minus m squared minus 4n. Okay, then you add 2m. 2 m. Okay, minus m plus 2m, it's m. Okay, then the answer is going to come out of this over 2. Okay, now you have this. So what then do we have here? Okay, let's check. Okay.
Why is there 2m?
Okay, because now is the LCD here. If you have the LCD is 2.
Okay, I see.
Yeah, the LCD is 2. So if you have 2 divided by 1, it's a 2 times m is like 2m. But now we have the 2m minus m, which gives us exactly m. Okay, this gives us like x values. Okay. What is the difference between this? So the y, they look very much the same. Okay, because we got y to be m plus or minus that. And x is also m plus or minus that. So they're the same. Yeah. Yeah. They look very much the same. But now we must get what? The sum of the squares. So we must get x squared plus y squared. And then see what answer we're getting. But the x is m plus or minus the same thing. And the y, they just like equal this. Okay? They look very much the same. But let's get the sum of these squares now. Okay, so let us actually continue. So what we're going to do, we're going to add them up and then and take the squares. And take the squares and then see what the result we're getting. Okay, right, practicing, yeah, but a very interesting problem though. All right. Let's check. Okay, let's do this. So now we're gonna have x squared plus y squared, which is the sum of the squares. What is x squared? It is m plus or minus the square root of m squared minus 4n divided by 2. Okay, you square this. And then the y is the same thing. M plus or minus the square root. M squared minus 4n divided by 2. Okay, so if you square these things, what do you get? Because you're squaring like the same thing. So if you're squaring the same thing, what would this mean? Okay, so what this would mean would be, it's 2. These are like terms. You add them up. So it's 2m plus or minus m squared minus 4n over 2. Okay, these and that are the same. So it's 2 of these. Right? So if it's 2 of these, then you square everything. It's 2 over, what is the 2 squared? It's a 4. You square the m. You square the m. You have the square root. And then you have plus. You square this, which becomes m squared minus 4n. Like this. Okay? So this will be the sum of the, find an expression for the sum of the squares of the two integers. All right. So this must be exactly what we're getting. Okay, you can simplify this. Okay, so this might require you to actually just work out your algebra and see what you get. So, right, it doesn't look like, obviously, I mean, we need to simplify to see which one it is. So, because the final expression for the sum of the squares, so it means that we must square these things and find the sum. So it is 2 over that. 2 over 4 is 1/2. Okay, yeah, but it's not. It's not. Okay. So it's m squared. Okay, it's 2. M squared and m squared is 2m squared minus 4n plus or minus 2 the square root of m squared minus 4n, like this. Okay. So now if you get to this, what exactly is the meaning of this? Can this be simplified to anything that appears there? Can this be any of this? That is what you need to think about. Okay. Right. Can it be simplified to any of this? Well, obviously, not very, okay, we're right back. Not very clear in terms of how these can be simplified to any of this. Right. But now you can multiply it through by the half, getting m squared minus 2n plus or minus multiplied by 1/2, and you have m squared minus 4n. Okay, I'm just seeing what this is going to give, right? So if you get to this point, what exactly do we have here? What exactly do we have here at this point? Right, so obviously there's more that needs to be done here at this point. For instance, if you take the plus, can it be simplified to any of these? You can see some of the expressions like the m squared minus 2n. It's there. And but there's an extra. There's an extra plus or minus term. Right, there's an extra plus or minus term. So obviously you need to still do a little bit more. But the question is, therefore, can these be simplified to any of this? Well, it doesn't look quite easy to simplify to any of this. Right, so what does it suggest? What does it suggest? What do you think, Noah? Okay. Right. No, no, yeah, if yeah, if ever doesn't work out to any of the given options, I would have to see maybe there is an error that was made. So I'll have to cross check and see.
Yes, but we were close.
We're close, yeah, but yeah, that's it. Because now once again, if a situation like this happens, you need to read the question again and pause and be like, have I read the question well? Have I like understood the question? Right, two integers have a sum of m. So there are two integers whose sum, when you add them up, you get m. And a product of n. You multiply them, you get n. Then you need to find an expression for the sum of the squares. So you need to be able to get x squared together with what? Together with y squared. Okay, there are too many ways to do this particular question, and I know that there are smarter ways. If you find the sum of the squares, okay, yeah, there's a nicer and easier way to do it. I was thinking about that, but I wanted to do it the most natural way. But now, one way you can do this question, a little bit tricky, is to get the squares out of this. Get the squares out of this. So if you have the x and the y equals m, you can get the squares out. How do you get squares? You square both sides. That's one way you can do it. You square the left, you also square the right. And if you do that, what do you achieve? It will be x squared 2xy, y squared is m squared. And we got the answer. So that wondering that long method I expected it to work because it was finding the answers there. But what is the xy? The xy is what? It's n. So wherever there is xy, you can put n, and then you have y squared, which is exactly m squared, which means the sum of the squares, x squared plus y squared, is actually m squared minus 2n. Okay, and the option is B. What do you think, Noah? I mean, I expect the other one to work. Okay, it would have been, it is the case that, you know, maybe there was an error in the calculation. But yeah, okay, because it was a bit long.
Yeah, the quadratic one,
yeah, okay, yeah, it might have been that. But I expected it to work out to one of these. But I realized that, okay, one way to do these is to manipulate these and be like, okay, you have the sum of the squares. The sum of the squares you need to compute. So obviously now sometimes you need to think outside the box a little bit because, yeah, these are like simultaneous equations, but I realized that, okay, you can get squares by squaring both sides. And then you have the xy term. But they gave us that xy term is what? Is n. Wherever there's xy, you can put n. And therefore x squared plus y squared is m squared minus 2n, meaning the correct answer is B.
Okay, now I see it.
Okay, yeah, but yeah, there are too many ways
Yeah.
to do it.
Yes.
Right. Any
Okay.
question? No. Anything to add or remove?
No.
Nothing. Okay,
No,
let's
thanks.
move on. Okay, let's move to the next one. Okay, let's look at this one. Okay, what are we supposed to do here? Here we have been given 2 to the power x plus 2. We have been given 5 to the power 2 to the power x. Excuse. Right. So we have been given 2 to the power x, which is 5 to the power y plus 1 minus 5 to the power y, like this. Okay. So yeah. And then we need to find the value of x minus y. So the question is x minus y is equal to what? Okay, what do we do here? I mean, there are too many ways to do it. And sometimes you can see there are like shorter ways and longer ways of doing this. But yeah, there are too many ways to do this one.
Okay, so we're going to
Yeah,
factorize
we can
2 to the power of
factorize
x.
2 to the power x, right? And then now this one you can have 2 to the power 2. Okay, yeah, there are too many ways. Maybe I can try a little bit one more step. You see, the idea is not you just memorizing this. Is 2 to the power x and then 2 to the power 2. And then you have 2 to the power x equals 5 to the y, 5 to the 1, 5 to the y. Okay, yeah, something like this. 2 to the power x is sort of a common factor, giving us 2 to the power 2 together with 1. There's 5 to the power y, which is 5 minus 1. Something like that. Okay, this is possible. It is our hope that it's going to work. It's going to work out. But obviously, you need x minus y out of this. So let us see how we can get x minus y. So you have 2 to the power x. What is 2 to the power 2 plus 1? It's 5.
5.
Okay, good. And then it's 5 to the power y. And then 5 minus 1 is a 4. I'm sure that this will be pretty close to the answer. Yeah. But what do we do? Okay, there are too many ways that we can do, but yeah. What is the most immediate thing to do?
Maybe you're gonna say
Yeah.
2 to the power of x divided by 5 to the power of y.
Well done. 2 to the power x divided by 5 to the power y. That is profound. It's equal to, maybe. Is it equal to?
Is equal to 4
5 to
divided
5.
by 5.
Well, it is possible to do this, but does it take us closer to the answer? That becomes sort of the question. Yeah. Does it take us closer to the answer? That becomes the question. Okay. So anyway, obviously, I mean, there are many things you can do at this point, but the question is, what do we do here? Okay, because this thing here can be written as 2 to the power x divided by 5 to the power y. This reminds me. And then this one is actually 2 to the power 2 divided by 5, like this. And now you can divide this one. Okay, yeah, we got the answer already. Got the answer, because the 4 can be seen as 2 squared, yeah, but it's also 2 times 2, which is 4. You divide, yeah, you can divide by 2. So if you divide by 2, it's going to be 2 to the power x minus 1, 5 to the power y, 2 out of 5, like this. Okay. Okay, yeah, we'll get something like that. And now we are just very close to the answer, like inches to the answer. Inches to the answer. So if we have this 5 to the power y, what exactly can we be able to achieve here? What exactly can we
How do you get 2 to the power of x minus 1?
Okay, now how do we get 2 to the power of x? We divide it by 1 factor of 2. So in other words, if you divide by 1 factor of 2, there's a 2 that's going to be like in the denominator like this. But if the 2 is in the denominator, then we can take it up because it is to the power 1 here. So if you take it up, it's going to become what? It's going to become like x minus 1. So it's basically the 1, the power 1 is going to, the exponent 1 is going to become a negative 1. Well, there are just many ways to do it.
Oh, okay, I see.
Yeah, there's just too many ways to do it, but yeah, I have sort of, okay, but think about this. What else do we do? Right, what else do we do at this point? Okay, right, okay, yeah, this is a very interesting equation.
Maybe
Yeah,
this 5 at the bottom,
yes,
the denominator.
yes,
Maybe you can break it up.
we can break it up. Yeah, I agree with you now. Never mind. Obviously, we're reasoning together. Okay, there are too many ways to do it. But if it at a time that, I mean, all these things are possible, but we can even change the train of thought. We can change the train of thought. We can think differently and be like, all right, now what we can do here is 2 to the power x times 5 is 5 to the power y, and the 4 is 2 to the power 2. 2 to the power, this one, when you divide by it, it's going to develop a negative exponent like this. And the 5, when you divide by this, it's going to develop something like that. Okay, I'm trying to cut out on some steps here. But when you divide by this, because you want to put that, you want the 2s to be together. And now, if you divide, in other words, in mathematics, when you have 2 to the power x to divide by 2 to the power 2, what is this? It's 2 to the power x minus 2. Okay, so it is possible to do that. But also, if you divide by 5, you have 5 to the power y, you divide by 5. 5 to the power y divided by 5, so it's going to be 5 to the power y minus 1. Okay, so, and hence this. So the question then is, what actually do we do at this point here? What actually do we do at this point? If you have this particular equation, exactly what becomes the result? Okay, there are too many ways, obviously, there are too many ways to solve this one, but there are too many answers to this.
Try to change 5
We can
to
try to
have a
change
base
5.
of 2.
A base of 2 there, that's the thing, well done. But 5 is tricky because the only factors it has, it's just 5 and 1. I agree with you
Can you
there.
say, okay, can you say like 2
Yeah.
times 2 plus 1?
Okay, yeah, 2 times 2 plus 1. Well done. Yeah, we can do that. But normally we always need products because this sum is gonna I agree with you there, but this sum is gonna make things a bit hard for us. Because we're gonna raise it to the power of y minus 1, and it doesn't quite easily dissolve. Anyhow, yeah, so you think about it and see what you do. Okay, the bases are different. Under what conditions would these be equal to each other? The bases are different. Under what conditions would these be equal to each other? Yeah. It's when these two, if these two happen to be equal to each other, and each one of these becomes what, for example?
It's 2.
Okay, yeah, this is very, very interesting. Right, very, very interesting. There are tons of ways to do it, but we need to find the difference. We need to find the value of the x minus y. So, and no, often than not, they set questions like this in the metric exams. And obviously, because the bases are different, the only way that these can be equal to each other is if the numerators, the exponents themselves. Okay, now this is sort of one case, but please, it's not general, this. You look at the general, it's not general. Okay, don't like doing things that are not general. Okay, but yeah, okay, I'm going to explore this. But I want to indicate, as I do this, that is not general, but I'm going to do a general solution. Right, it's not general, but now if the bases are not if the bases are 2 and 5, then you can say if the exponent is 0 here and the other one is also 0, that would mean 2 and that would mean 1. in what is x minus y? 2 minus 1 and x minus y would be 1. Meaning this would be obviously sort of a solution to this particular problem. For integer, yeah.
So you assumed that
Assume that because the top
power is
above
0.
the powers are 0 because the bases are different. So
Okay.
the only way that this left can be called derived is when the top is 0 and the top here is 0, so that the x is 2 and y. But you see, the actual solution to this is very complex than that, because what would the actual solution to this be? Well, you need to solve for x. Make x the subject. After having made x the subject, then you manipulate. Okay, I'm going to show something here. Right, I'm going to show something. For example, we're going to say we got to this point. Okay, this point is 2 to the power x minus 2 is equal to what? It's equal to 5 to the power y minus 1. Okay, now we can solve for x and or y here. Okay, in financial math, I know the logs. In financial math, if ever you have 2 to the power n is equal to 3, what is the value of x? You know, in the compound interest calculations, you find something like this. What is the value of n? You simply say n equals the log of 3 base 2. Right? We always do this. So the base here of the power becomes the base of the log. So in the same way, you can think of these in the same way and think of these as one big block of one thing. And if you do that, look at it like financial math. So this whole thing becomes, without complicating things, becomes actually the power, because we want to solve for the power. So it becomes that the power, which is x minus 2, becomes the log of the whole thing, base 2, like this. So that if you exponentiate again, this one becomes the base of the power. It becomes exactly that. So it takes you back there. Simultaneously, I mean, this would be sort of a very correct way of doing it. And then now you bring the y minus 1 down. And in general, this is how you can do this particular question. But I'm sure that the idea here was to seek for integer solutions. Right, so you get to this point, and then we have x minus 2, which becomes y, the log of 5 base 2, minus the log of 5 base what? Base 2. Like that. Okay. And then now, let's see what we get. X equals y, the log of 5 base 2 minus the log of 5 base 2 plus 2. Then this becomes sort of, okay, this becomes a x in terms of y, x in terms of y. Okay, so if it's x in terms of y, you can see what to do. You can see exactly what to do. Right, you can see precisely what to do. And then you got the x here, then you can actually then be in a position to look for x minus y. So what would x minus y be, for example? Okay, so this would be sort of the general equation you can achieve. But obviously at this point, I'm sure that the examiner wanted this. They actually expected a simpler version of the answer than a more complex version of the answer. So the answer would actually therefore be x minus y equals 1. Okay, yeah, but this is also possible, but this is a more general way to think about it. But this gives us an equation in terms of x and y. And this equation in terms of x and y is like a function. Like x plus y equals 4. Okay, so it is an equation. So, but if you have an equation like this, then how do you get x minus y? Well, the truth is x minus y will be many, will have many values. Because this equation is, what kind of an equation is this? Okay, it is a linear equation. It's like a straight line equation. Why is it a straight line? Because there's the log in it. Okay, so it is an equation of the form y equals mx plus c, this. But you see, an equation of the form y equals mx plus c, the question is how many solutions exist? The solutions exist as much as the graph can go. Okay, these are like, it's a straight line graph if you draw the graph. So how many solutions? The solutions are the points on the graph. How many points are there on this graph? The truth is there are infinitely many. You can't finish the points because this line goes here and goes there. So yeah, I'm sure the examiner wanted this one, x minus y equals, by just saying the bases are different. The only way that these, one way, perhaps obviously not the only way, but one way. In other words, there is one solution. One solution exists when both the top and the top are 0, because if this is 2 to the, what is 2 to the power 0? 2 to the power 0 must be 5 to the power 0, because 2 to the power 0 is 1, 5 to the power 0 is what? It's also 1. So that you have that 1 is equal to 1. It is true. So it's when x minus 2 is 0, y minus 1 is 0, and then you get the values of x and y. But these are not all. There are too many. There are as many as this straight line can be drawn. Here we make y the subject, and you can write this in the form y equals mx plus c. And then now, how many solutions are here? The solutions are as many as the points that constitute this line. How many points are there on one line? Whew, this line has many, like infinitely many. Okay, infinitely many points. So yeah, it's a consequence. We got x equals 2, y equals 1, because x minus 2 is 0, x equals 2, y minus 1 is 0, y equals 1. And then we have x minus y. 2 minus 1. What is 2 minus 1? It's a 1. So x minus y is 1. And then the answer is B. Okay, yeah, there are too many ways to do it. But yeah, you see, some ways sometimes do not work beautifully. Some ways can be correct, but can like make it more messy and more difficult, more complicated. And then you find yourself now writing too many things, and time is of essence here. Most of the time, the students do not finish this assessment because it's like lots of things. Any question? No.
No, thanks.
Okay, good. We move on. Right, we're exploring different ways of doing these questions. Okay, let's look at this one. For how many integer values of n is this an integer? Hey, sometimes again, we should get it. How many integer is this an integer? Now they've given us n plus 3 divided by n minus 1. For how many integer values of n is this an integer? They are saying this is an integer for some values of n, but for how many values of n will this be an integer? So there are those values of n for which this is going to be an integer. But how many integer values of n? What are the integers? First and foremost, okay? Integers are minus 3, minus 2, minus 1, 0, 1, 2, 3. We can put 4 and so on. 5 up to 100, up to a billion, 1,000, whatever. Okay. But the question is saying, for how many integer values of n is this an integer? So what do we do? What do we do? Okay. So we need to, by trial and error, right? Trial and error. Okay, let's do this by trial and error.
Simultaneous equations.
Yes, you can do like simultaneous equations and stuff. Okay. Yeah, but how many integer values? These can be an integer. So it can be one of these, but how many integer values of n? So in other words, you can put an integer. Let's try and put 0, n equals 0. Okay. I'm starting here going that way, and then you can go in the reverse. So let's see. This one is 0 plus 3, which is 3 divided by minus 1, which is minus 3, an integer. So, which means therefore that n equals 0 works because it's giving us an integer. Okay, I'm just exploring. Okay, now we're putting 1. 1 plus 3 divided by 1 minus 1. Oop. Not an integer because it is undefined. Why is it undefined? Because it's division by 0. And then now, if you take n equals 2, you put here 2 plus 3, 2 minus 1. 2 plus 3 is 5 over 1. An integer for n equals 2. N equals 3. Okay. Okay, you see there are a couple of numbers. So yeah, I'm sure that it won't be too long before we sort of able to conclude. Now n equals, okay, n equals 3 here. 3 plus 3, 3 minus 1. What is 3 plus 3? 6 over 2, 3. We happy? It's an integer. 3 is an integer. Okay, let's explore more. What about if you try n equals 4 and you plug it in here? And then you have 4 plus 3 divided by 4 minus 1. What is 4 plus 3? It's 7. 7 over 3. It is not an integer, okay? So let's try and see. Okay, it's like we're gonna, right now, are we done? In terms of, let's check if we can't get other integers here. Okay, we tried n equals 4. Let's do n equals 5. Put 5 there. 5 is gonna be 5 plus 3. 5 minus 1. What is 5 plus 3? Is 8 over 4 is 2. We're good. It's an integer. N equals 6. Right, we have 6 plus 3 over 6 minus 1. A 5. None over 5, it's not an integer. N equals 7. 7 plus 3 is a 10 over 6. It's not an integer. N equals 8. Okay, with 8 plus 3, 11 out of 7. Not an integer. Okay, n equals 9. We have 9 plus 3, which is actually 12 divided by n equals 9. That's what we're doing now. And then now we have 9 minus that, which is exactly 8. Okay, and then n equals 10. Okay, the pattern emerges here. N equals 10. You have 10 plus 3, which is 13 out of 9. Ah, and so on. I mean, what are we able to see? What are we able to see? Okay, the question is how many? Okay, we got, what about minus? Let's put minus 1. Okay, now we're moving in the opposite. So if you have n equals minus 1, you put minus 1 here. 3 minus 1 is a 2. Minus 1 is minus 2. And this is minus 1, an integer. Let's put n equals minus 2 here. You put minus 2, it's going to be 3 minus 2, which is a 1, over minus 2 minus 1, a minus 3 is not an integer. N equals minus 4. N equals minus 4. We have minus 4 plus 3. It's minus 1, minus 5, so it's not. When do we have the last one? Integer when we're moving in the negative directions. In the negative direction, so we sort of are able to see like a pattern, but also we're able to see, okay, like at minus 1, we got an integer, so that was 1. And then at minus 2, we're out. So in the negatives, minus 1, n equals minus 1, we got an integer minus 1. But when we put n equals minus 2, we got like minus 1 over 3, which is not an integer. And also when it equals minus 3, okay, we jump to minus 3. Minus 3 plus 3, 0 over minus 4, 0, 2, 1, 2. And then minus 4 is not working because it's giving us minus 1 over 5. Minus 5 is not going to work. Minus 6, so there are only 2 in the negative. And then in the positive, okay, 0 is fine. So this is like 3, 1, 2, 3. It's undefined here. 4, 5, not 6, not, we counted 6. And that's sort of the mouse. So the rest are out. That question, think about this one now. Yeah. And obviously we can have another way to do it that's much easier. But yeah, obviously this one is like trial and error because the question is how many of them do we put 1 and see, okay, does it give a value that is in this set Z of integers? If it doesn't, then you try, and then be able to see that only 6 of them are going to work. Only 6 integer values of n are going to work. Right. Any question, Neo? Any suggestion here on this one?
So how do you know which number to stop at?
Okay, that's a good question. How do you know which number to start off with? Well, you cannot know. That's a good question. There's no way. And so, as we said here, what is it? It's
Because you
trial.
ended at 10.
Yes. I went as far as
So you
10.
couldn't go further than that.
Okay, that's a good question. We could go further than that, but I realized that it was not gonna really help us because the difference is 1 less in the denominator. So for the numbers that are more than 10, there's no way those numbers that are 1 less can divide, because to give an integer. Like even if I go to 20, if it's 20 divided by 19, it's not gonna even work, because it's just 1 less. So if you get something like 20 over 19 like this, it's not gonna divide through. So the numbers that can divide through are much smaller ones. Even if I go to 40, if it's 40 out of 39, then 39 can never divide into 40 to give us an integer. The numbers that get divided into 40 are numbers like what? Factors of 40. But the factors of 39 is not, it cannot be a factor of 40. Like the 9 can divide into a number if ever it is a factor of the numerator. And now 13, it does not have the factor 9.
Oh,
So
now I
that's
see.
yeah.
Thanks.
So I realized that even if I can go on to 100, it's gonna be like 103. Let's put 100. If you put 100, it's gonna be 103 divided by 99. Okay, but you still can see that this 99 is so big because the divisors of the number must be like 3, 5 small ones, a 20 with large differences. But the 99 is way too close to this in size that there's no way it can go into this, So, and hence 6. But also, we're able to see that A was 1 and B was 2 and C was 3 and we got 6, the largest one. Yeah, it worked so well. Some students could get only 1, 2, 3, but at least we exhausted a lot of the possibilities. Then we're able to see 6 possible integers obtained by just trial and error like that. Okay, we'll move on to the next one now. All right, let's see the next one. 4-man. Okay, 4-man can lay 3,200 bricks in 6 hours. How long will 3-man take to lay 800 bricks? Okay, what do you think of this one, Neil? So we're saying if we have 4-man, 3,200 bricks, 6 hours. 3-man. Okay, it's like we've been seeing the answer here by just writing this. 3-man can lay, 3,200 bricks. 3-man can lay like 800 bricks. How long? X. We already have the answer. We already have the answer. We're just writing this. These are ratios. One way to do this is just to divide this and this and put an equal sign here. And then you cross multiply. That's what I'm saying. But yeah, as much as there can be many ways to do it, but yeah, it's just one way to do it. So you then, if you just put in a division and an equal sign, and then you can have like 3,200x is equal to 6 times 800.
So you just use the information you are given
Yes, that's the
to
information
find out
given.
what you want.
Yes, yeah, the ratios. So now we have we have this divided by, you divide by the 3,200. And this must be the answer. But you see, upon division, these two zeros cancel out. You have 6 by 8 divided by 32. What is 6 by 8? It's 48. You divide by 32. Okay, let's simplify this. Let's divide through 16. 16 goes 2 times, but 16 goes 4 times. Yep. Yes. 16 goes 4 times into that. And the answer is 2. So it's exactly 2 hours. Okay. Just one creative way to do this. But there are other ways to do it. But I feel that this is the easiest one. Because the minute they say 3,200 bricks to 6 hours for the 4-man. But you see, another student can look at the fact that the men are 4. And these men are 3. And then can complicate things. Because you're dealing with the 4-man, the number of the men with bricks and the hours. Okay. It can be made nasty and unusually messy. So the correct answer is exactly 4 divided by 2, which is 2 hours. Any question on this one, Nebo? Any input?
So this is ratios. It's fine because
Yeah, quite short.
straightforward.
Quite short. Yeah, straightforward. I feel it is straightforward, but there are too many ways to do this. Oh, you can think, what other way is there? You know, can use some ratios and be like, what other way is there? You can also do this. Okay, just thinking. You can also do this just before in passing. You can use this in chemistry when you do what you call stoichiometry. Okay, you can use like the stoichiometric methods. What would a stoichiometric method be? Like you have a certain number of moles of hydrogen, but also you have the equation that shows the ratios of the number of moles. So this is sort of a similar scenario. Just thinking of that. So you can then say, what have we been given? Another student can come and say, okay, here we've been given that 3,200 bricks together can be put in 6 hours. Can be put in 6 hours. So now you can then come and then say, if you have 800 bricks, 800 bricks, then you multiply by, you want the hours, so you put the hours on top. You have 6 hours, you divide by 3,200 bricks. Okay, just thinking there are too many ways to do this. So in any event, you can have this, and then you divide, the bricks cancel out, and then you're left with the hours as the units. The 2 zeros cancel out, and then you have 8 by 6 divided by 32. You divide by 2, whatever, you know. Right. Yeah, you have 48. 8 by 6 is 48 divided by 32, and 16 goes 4 times. 16 goes twice, and 4 divided by 2 is 2 hours. Okay, yeah, there are other ways to obviously do this here. There are other ways to do this here. Yeah, but any question, Noah, on this? You think about it, I'm
No,
sure.
I don't.
You think about it, yeah. Okay, I'm just looking at, obviously. I mean, there are many possible ways to sort of like think of this and sort of analyze it and see how best we can do this. How best we can do these. Right. Just thinking. Just thinking. There are too many ways. Yeah, some of the ways can complicate this, but let's move on. You can always find other ways to do it. Let's look at Mala. Mala is given money to buy supplies for a class party. Okay, they say go and buy supplies for a class party. She spends 20% of the money on sweets and cool drinks and 10% on paper plates. Okay. Then she spends 40% of the money left over at this stage on sandwiches. She buys some sandwiches and then she eats these sandwiches. That reminds me when I was young, always had to comply with the rules. If I've been sent to use 10 rand, I'd use 10 rand. Because if I use 12 rand, then the fire was going to come down because my mom was not going to let it go. Be like, hey, I said use 12 rand, now you used your own. I said use 10 rand, now use 12 rand. Why? You don't listen, whatever. Okay.
Yo.
So, I can imagine. Okay, but now, okay, that's the situation. But she spends 40% of the money left over at this stage on sandwiches. Okay, she buys some sandwiches for herself to eat. But remember that Mala is given money to buy supplies for a class party. She was just supposed to buy supplies. Anyhow, she then has 168 rand left over. Okay, how much money did she spend on paper plates? Okay, let's look at this. How much money did you spend on the paper plates? So obviously a couple of things here. Like Mala is given money to buy, supplies for a class party. She spends 20% of the money on sweets. The sweets and cool drinks. 10% paper plates. And then she spends 40% of the money left over at this stage on sandwiches. She then has 168 rand left over. How much money did she spend on paper plates? Okay, what do we do here? So obviously, we want to say there's an amount of money that was spent on paper plates. So there are too many ways to do this question. But now you can then say let X be equal to the amount of money given. Okay, let X be an amount of money given. Let X be the amount of money given. Okay, so if X is the amount of money given, then you can do the rest of these acrobatics. Right, she spends 20% of the money on sweets. So if this is the amount given, 20% of it, 20% of this money, 20% of the money is spent on sweets and cold drinks. And then now 10% on paper plates. So 10% of this money is spent on paper plates. So the whole money is there and it's like a pie chart. And just thinking, there are too many ways to do it. 20% on something, some 10% on the paper plates. But obviously, I mean, you understand that this Mala wants to do class party, a class party. So in the class party, they're gonna like they want to eat a little bit of the sweets and the sweets must be put on plates. And the sweets cannot just be given on bare hands like that. Okay. All right. So anyhow, we sort of get the logic here. Right. So, but you spend 20% on sweets, 10% on paper plates. She then spends 40% of the money left over at this stage on sandwiches. So she then spends 40% of the money left over. What is 40% of the money left over? Right, so it is 40% of the money left over. The money left over would be the total amount of money minus 20% plus the 10%. Okay, yeah, minus 20% of X in that, minus 20% of X and 10% of X, like that. So that is the money left over. So the total amount of money given was X. But we know that 20% has been used, 10% has been used. And now she then spends 40% of the money left over at this stage on sandwiches. So it's 40% of the leftover, of the X minus whatever has been used. Okay, now she then has 168 Rand left over. So in other words, after she has done all these things here, she has 168 Rand left over. What does this mean? Okay, so she used all these particular percentages of the money, but after having used all this money, 168 Rand was left over. In other words, from the money that was given, because she was given X, right, she used every single bit which was part of it, but 168 Rand was left. So what is the meaning of these? Okay, okay, that's interesting. Well, it means that you need to think outside the box a little bit and say the total amount of money that was given was X minus all these uses of the money, X minus all these uses, then it is 168 Rand that is left. All the money is X. But now you remove the money that was 20%, the 10%, the 40%, then you get 100 and what? 168%. 168 Rand left over. How much money did you spend on paper plates? So yeah, this is sort of the equation that obviously one has, and you need to be in a position to manipulate these and solve for X. Let's just do it together. So it means that we have X minus, what is 20%? It's 20 divided by 100, 0.2X. This one is 10 divided by 100, 0.1. Okay, 0.4, which is 40 divided by 100, X minus 20 divided by 100, which is 0.2X, 0.1X, and it's 168. X minus 0.2, 0.1, 0.3X, 0.4. X minus 0.3X, which is 0.2, 0.1, 0.3. Okay. And this is 168. Let's check what this is going to give us. Okay, let us calculate these together. What is all this here? What is all this here? What is all this here? Okay. Remember, no calculators are allowed here. So yeah, we have some decimals a little bit here from the percentages. So let us actually just do this. Let's just get it done. Okay. So now we need to solve for X out of this. So which means that is X minus 0.3X, 0.4. Okay. When you have X minus 0.3, what is X minus 0.3? Right, so X minus 0.3, it's a 0.7. Okay, 0.7X. And then this equals 0, like that. And then, what is this? Decimals. Right, no calculator used here. It's allowed. No calculator is allowed. Okay, let's move. Let's move. We need to. Okay, no, it's 168.
Why is it equal 0? Isn't it?
Yeah, well done, well done. Well done. No, it's 168, right? It's 168. Well done. Okay, that's gonna be huge disturbance. 168. Okay, we need to solve for X out of this. Okay, we can do it. What do we do? Okay, I'm gonna just divide a little bit here. Right, we can distribute by the minus here if we wish to. Okay, like X minus 0.3 plus 0.4 times 0.7x. Okay, but you see the times can look like an x, or it's a big trap. Let's just write it. Let's put some brackets around it. 168. Okay, what is this? What is x? Okay, there's an x here. 0.3x. So what is this? X minus 0.3. It's like 0.7. It's like 10 minus 3 is 0.7. X 0.4, 0.7x is 168. Okay. 0.7x. You pull out 0.7 and then, okay, you don't need to factor out, but you can add the things up. Let's add the things up. You have 0.7x and then you have 0.4x. 0.7 plus 0.4x is what? It's like 1.4, because it's like 1 plus 0.4. 1 plus 0.4 is 1.4. And then there is 0.7. X. 168. Right. And then you have X. 168 divided by 1.4 times 0.7. Okay. Yeah. What is this? Okay, we just need to simplify these. And it's going to give us the answer. Okay. It's going to give us the answer. So you can multiply this by 100. Multiply the top by 100. Multiply the bottom by 100. Which is
Isn't there
1.
supposed to be x by 0.7?
Please come again.
0.7x.
Let me see. Okay. I'm checking. So obviously we have
You're going
yes.
to say x, right?
Yes, we're gonna say
X.
x.
Oh, sorry.
Okay, that's fine. It's 168 divided by, so we divide by 1.4. But
Okay.
now we also divide by 0.7. Okay, it's just many
Okay,
points. Yeah, it can be confusing. Okay, right. We need to solve for x. We need to simplify this one without a calculator. But we need to move the decimal point once to get rid of the fractions. So we're going to multiply by 100 and 100. Why? Because if you multiply this one by 10, it's going to become 14. 1.4, the decimal point moves to the right. Decimal point moves to the right, multiply by 10. So we need a 10 and a 10. But on whatever we do, the denominator must be done to the numerator. So you multiply by 100 there. Okay, but the 10 is going to make this one 14, and the other 10 is going to make this one 0.7. It's going to become what? Like 7. Okay, let's check if this is going to be nicer. Okay, let's do the arithmetic. 7, and then the top is 16800. We're good. Now we need to just deal with this. Okay, we're done, but we just need to simplify this. How do we simplify these now?
Why did you multiply by 100 over 100?
That's a good question. Why did I multiply by 100 over 100? Because I wanted to get rid of the 1.4, but for us to make 1.4 a 14, you need to multiply by 10, because 10 is the power to move the decimal place once to the right, making the 1.4 a 14. So a 14 is easier to deal with than a 1.4. But also the 0.7, it would be ideal to make it like a whole number. So we need to multiply it also by 10. Multiply this one by 10, multiply this by 10. That is like multiplying this by 10, and that by 10 is like multiplying by 100. But we can't just multiply by 100. We must multiply by a 1, because then if you just choose to multiply the bottom by 100, then it's not mathematically correct. So you multiply by 100 over 100, which is like a 1. Okay, so in this case, therefore, this becomes mathematically correct. Right, so think about it, but it was convenient. But yeah, because these fractions will be tricky to deal with otherwise. You can think about how we can deal with these fractions. It's not going to be a bit easier to deal with these fractions. So are we good? We're so good. We're so good. Okay, let's continue. Let's simplify this one now. 168. Where does this 168 come from? Let's get the factors of this 168. Anyhow, it was 168 left over, but this 168 is sort of divisible by 2. What is 168 divided by 2? What is 100 divided by 2? 100 divided by 2 is what? It's 50. But if you divide 168 by 2, it becomes what? 168 divided by 2. Okay, it's 100 divided by 2 is 50. 68 divided by 2 is what? It's like a 34. So this is like 84. 2 times 84. Okay, we're just trying to simplify these numbers. No calculator. So it is 2 times 84 divided by 2 by 7 by 7. Because 14 is 2 by 7. Okay, right. And this is enough to then tell us 2 cancels. 84. What is 84? 84 is 2 times 42. 42 is 2 times 7 by 2 or 6 by 7. 42 is 6 by 7, right? So yeah. So that in the end, then, this 84 can be seen as what? What will 84 be seen as? 6 by 7 by 100. You divide by 7 by 7. Okay. 7 divides. Okay, sort of 7 divides. Then what else do we have here? So now you have like 600, like 6 by 100. Okay, okay, right? So we have that. So you'd have like x is equal to 6 by 100 is 600 divided by 7. Right, so what is 600 divided by that? Okay, so but this is not the answer yet, because the answer is how much money did you spend on the paper plates. It means therefore that you'd have to take this money and get 10% of it, because 10%, yeah, she spends 20% of the money on sweets and cold drinks and 10% on paper plates. So you need 10% of this. So the answer would be 10% of this, and we already got the answer. I'm sure it is the answer. Okay, the examiner was nice to us because now we can get 10% of this. 10% of this, what is 10% of this? It's like 10 over 100 of the x. Right, so yeah, I'm glad that I actually created more space. So we're saying x is actually 600 over 7, and we need 10% of the x. 10 over 100, x. 10 over 100, x is 600 over 7. Like this. Okay, yeah, 10% of the x. So yeah, we're good. Yeah, the 100 goes through, giving us 10 by 6. 10 by 6, it's 60. 10 by 6 is 60 out of 7. Okay, 60 goes how many times into 7? Okay, you can try the factors of 7. 7 by 7 is 49. 7 by 8 is what? It's 56. Okay, and then, yeah, that is the maximum. So 7 goes what? Goes 8 times. Right, goes 8 times into 60, leaving 4 out of 7. Right, so let me see now. How much money did you spend on the paper plates? Obviously, she spent 10% of the x. I'd have to check why that is very different, not because it would be 8 in that. So, and in the end, 8 would be, that is the amount of money. So that would be 8 rand and this number of cents. But you can see that it's a little bit further away from that. So I need to analyze and check. Now, she spent 20% of the money on sweets and 10% on paper plates. She then spends 40% of the money left over on sandwiches. Right, 20%, 10%, 40% of the leftover. The leftover is the total amount of money minus this used. Okay. Right, I'm just checking. But now she then has 168 rand left over, and the leftover would be the total amount of money minus all the money used. Total amount of money minus all the money used would give us the leftover money. And the leftover money would be 168. Okay, yard 168 there. Right, I need to check if something is amiss. Something is really amiss. Maybe there is a small error. Right, there's more error because there's 0.3 here, 0.4. 0.3 x minus 0.3. I'm trying to check. So this one is x minus, this is 0.3. There's the error. There's the error. Because when we multiply it through by the negative, it was supposed to be negative here. Minus 0.3 minus 0.3 minus 0.4. Okay. So if it's minus 0.4, then you have this one is going to be 0.7 minus that. Okay. And then it's going to make a difference here. Because this is like 0.7x minus 0.4, 0.7x. So it's going to be like 1 minus 0.4 because it's 0.7x, 0.7x is common. So 1 minus 0.4 is going to give you 0.6. It's going to give exactly a 0.6. That's the difference it's going to make. So meaning therefore that, let's see, it's going to be 168 and this one is going to be 0.6, 0.7. So which is 0.6. Okay. So this one is going to be actually 0.6. It's going to be exactly 6 and a 7. Good. Okay, multiply by 100, like 10, 10 still. It's going to be, this one is going to be, if you move decimal point once by effect of 10, it's going to be 6, and this one is going to be a 7. Something like that. So, okay, it's taking us to this point. It's taking us to this point. So now in the denominator, it's going to be 6 by 7. Okay, so it's going to change the landscape here. And I'm just going to take it to the next slide. That is a bit more things. So, or more space. So now we get to this point. I'm going to remove this because it was a small error and need to just rectify that. So now the minus sign rectification. So it's going to, I'm sure, yield the one of the answers here. I was wondering why that would be the case. So let's check. What did you get X to be? So it's going to be 16800 divided by 6 by 7. Yeah. So X is 16800 divided by 6 by 7. Okay. Yeah. Mahler had like lots of freedom. We need to simplify these. It must simplify to one of these, but let us check. 168 we said is 2 by 84. 100. Divided by 2 by 3 by 7. 2 divides 8400 divided by 3 by 7. Okay, what is 84? We say it's 2 by 42. 42 is 6 by 7. 100. And then we have 3 by 7. Okay, like that. So just simplify this. Remember, there's no calculator that is allowed. We're just practicing how to deal with the numbers. And now, what do we get here? 7 goes through. 6 goes into 3 goes into 6, giving 2. Okay, everything divides nicely. And then you have 2 times 2 times 2 times 2 times 100, 400. Okay, yeah, it is the answer. It is correct. Because you're getting X equals 400, but we need 10% of this because it's not all, this is all the money. So in other words, Milo was given like 400 Rand, but 10%, it's the money we want. So you're going to get 10%. So you're going to get 10% of X, which will be 10 over 100 of X, 10 over 100 of 400. This one divides, taking 2 zeros, giving us 40. Giving us 40 Rand. There it is. So indeed, 10% out, she then has that left over. How much money did she spend on paper plates? She spent 10% of the money. She was given 400 Rand originally, and she spent 10%, 10% of 400. 10% of 400 is a 40 Rand. So in other words, she spent 40 Rand of the 400 on the paper plates. Okay, right. What do you think now? Yeah, any question on this one? But yeah, just some manipulation a little bit.
Yeah, I don't have any questions.
All right. That's fine.
It makes sense.
Yeah, it makes sense. Good. Uh-huh. This is what I'm going to give to you. I'm going to give to you. Let me know. What do we do first? That is how I'm not going to wait for you to do the whole thing. But what would you do first? Okay. Because I'm
I'm
just,
going to say,
yes. Because we're given this 3 or like that.
maybe you'll say 4 times.
Yes.
You will say 4 times 3 squared.
Yes, 4 times 3 squared. Yeah, that's
3
correct.
squared,
4
yeah.
times 3 squared, and then there's power 9. Yeah, something
And
like that.
then 3 squared in.
And then 3 squared, then there's n, something like that. Equals, yeah, that's okay. Perfect. I like the fact that you just changed the base to base 3, so that you have base 3 both sides. That's okay. Next.
And then there's a factor of 3 to n.
Yup.
So you're going to take out 3 squared in.
You're going to think you got 3 squared n. Well done, Neville. 3 squared n, and then you're left with what?
4.
Like 4 minus 1.
Minus 1.
Yes. Okay, good. Yeah, then what do we do? Because I want us to work through together than just waiting for you to solve the whole thing. And then at this point, what do we do?
3 squared n times 3.
3 squared n. Yeah, I can write like 3 squared n times 3 is 3 to the power 801. Okay, we're good. This was pretty easier than ever thought, I can imagine. Right, so we have 801, and then yeah. Then next, what do you do?
And then 3 to the power of 2n plus 1.
3 to the power of 2. Yes, well done.
2n
3 to the power of
plus
2n plus 1. Right, which is 3 to the power like 801. Okay, next.
And then 2n plus 1 is equals to 801.
Well done. The base are the same, so we equate the exponents. Meaning 2n is what? It's 800. Then n must be the same as 400 divided by 2. What is 400 divided by 2? 800 divided by 2, excuse me. Okay, because it's 800. 800. Yeah.
Yeah, 100.
Okay. 100. Well then, 100. And the correct answer must be option D, right? Okay. Yeah, that looks pretty easy. Because when to find the value of n, so always go back to the question to see if you answered the question correctly. Because I said find the value of n, and we found the value of n. Next question. Okay, I'm gonna give you this one. 13. What do we do? Okay, because this one says A cross B is A minus 2 times B. Okay, this one is called the binary. It's called a binary operation. Okay, then what is 7 by this? Okay, yep. What do we do here now? I'm giving you a chance because I know that yeah, we are
What is a
beyond
binary?
time. What is a binary operation? The word by means what? By means 2. So if you a binary operation is like our multiplication, it's 2 by 3. The multiplication works to combine like 2 numbers. 2 by 3 is what? Is 6. 2 by 3 is 6. And therefore, like these are binary operations, like 2 plus 3 it's a 5. These are binary operations because the plus only combines like 2 numbers at a time. So it's called a binary operation. It's an operation that operates on 2 numbers at a time. So what do we do here?
So that means it's A plus
Sorry.
B.
Okay, that's a good question. So obviously now, sometimes it's like this is different. It's not addition, multiplication, or division, but it is some operations that when you combine A and B, the answer must be A minus 2B. So,
Oh,
in other
oh,
words,
okay.
yes,
I
yes. So it's just some operation the examiner came with. I've seen this before in the NBTs, and this was just one question I saw in your document, but it is such that when you combine these two, the answer becomes the first one minus 2 times the second number. I mean, that brings us to saying, what would 5 cross 2 be? What did 5 cross 2, according to this rule? Because this is like a rule. Okay. According to this rule, you would have to take the first one. A cross B, you take the first one. And then the last one, B. What is 5 minus 4? It's exactly a 1. So that would mean 5 cross 2 is 1. Because according to this rule, is the first one minus 2 times the second one. So the first one is 5 minus 2 times the second one, 2 times 2. And 2 times 2 is 4. 5 minus 4 is a 1.
Yo, I don't understand. Can you explain again?
Okay, right. So let's practice with this binary operation. For example, according to this binary operation, we're going to say, because we're going to use it here to do this. But to use it here, we're going to use Bodmer's rule. Bodmer says we must deal with the brackets, so we're going to deal with the numbers within brackets. But now, if they give us a rule in mathematics like A cross B is A minus 2 times B, so the rule is motivated by the fact that we can do some numbers like 3 cross 5. What's the answer? According to this rule, if we then say 3 cross 5, just practicing before we tackle the problem. So 3 cross 5 is going to be, according to this rule, you say the first number, because the first number that you have, so the first number is like 3. Then you put a minus, then you put a 2 times the second number. The second number, it's B in the formula, but our B is like 5. So this will be 3 minus 2 times 5, 10, minus 7. Okay, let's do something. Like if we then say,
I understand.
anyway, I'm just
Makes
creating
sense.
these things to practice. Okay, right now 4 cross 2. What do you think is the answer to 4 cross 2? Just teasing. Before we tackle the problem.
4.
So if it's 4 cross 2, you then say the formula says A cross B. It's the first number, A. So our A here is like 4. Then you put a minus. Then 2 times. Then the second number is what? The second number is exactly 2. That's like our B, because the B is the number after the cross. And then now you then say 4 minus 2 by 2 is a what? It's a 4. 4 minus 4 is what? 0. Okay, yeah, we continue and try to check what we have here.
Okay.
Okay, now, what about if we say, yeah, anything like that? We can do. Okay, yeah, anything you can do. I mean, I'm just practicing. Well, practicing, then we want to tackle the problem. So what about if somebody says 14 cross 2? What is the answer?
It's going to be 14
Yes?
minus
14 minus, well done.
2 times 2.
2 times 2, well done, which is exactly 14 minus 2 by 2 gives us exactly 4, and then 14 minus 4 gives us a 10. Okay, let's come to the problem that they gave us. So now they then said we must do this one. So to do this one right now, we're going to proceed as follows. So we have 7 cross, in brackets, 5 cross 2. So now this is going to be cross. Yeah, so we start with the ones in brackets. So what is going to be
7 cross.
Okay, yeah, you can always do it that way. Yes.
And then open brackets.
Yes. Yes.
5.
7. Yeah.
Yeah, so then it's open bracket 5
Okay. Okay. Let me
minus
see. Open bracket 5 minus. Yes. Now you're on point.
minus
So dealing with-
2
Yeah.
times 2.
Okay. Yeah. 7 open bracket. Let me just say. Sorry. 7 open bracket 5 minus 2 times what?
2.
Times the 2. Well done. Like that. So yeah, you have this one. It's still there, but we're dealing with the 5 cross 2 first.
And then
Yeah.
it's gonna be 7 multiplied
Plus.
by,
Yeah. Then you deal with this one.
yes, then you say 7 multiplied by 5 minus 2. It's 4.
It's 4. Yeah.
Sorry,
Minus
6.
2 times
6.
4. And then here you have 5 minus 4. And then we can do the 5 minus 4. What is 5 minus 4?
Yes.
It's a 1.
Yeah. 1.
Okay. And
Yes.
then what do we do now? Now we have 7 cross 1.
Then
You're going to see a lot of this in
it's
computer science. You're going to see a lot of these things in computer science. Normally, these are common in computer science. Okay. Yeah. Okay. Then you have 7 cross 1. So you're back here. Right?
then it's
Mhm.
then you're gonna say, wait, let me see. You're gonna say 1 minus 2 times 1.
Okay. You're okay.
No, sorry, 7. Sorry,
7.
7
Well
minus
done.
2 times 1.
7 minus 2 times 1. Well done. Well done. Well done. Well done. Okay. So these are sort of the practice things you need to do. 7 minus 2. What is 7 minus 2? It's a
Which
5.
is 5, yeah.
A 5. And so, yeah, you can see one of the answers there.
Mm.
Right. Anyhow, yeah, it was an interesting one. I even put this on the cover. I even put this one on the cover page because I realized that it's an interesting one. But you want to see a lot of these things in computer science where there are these sort of operations that when you're writing the computer programs that do not behave like ordinary multiplication. So you wish to define an operation that can do something. Because this is very important in computer science. When you write a program that can do something, a program that can be used in the bank to give change in an ATM, which combines many things, like when you are at the ATM, you want to withdraw money, and you know you need to get change, or you are write a program that can be used in a kiosk. These vending machines. Vending machines, you put in money and you must get a difference. So what kind of an operation can do this? If somebody puts in 10 rand and they want to buy something for 5 rand and they want to get that 5 rand change, so that kind of thing. So these kinds of things therefore become so these kind of binary operations that are used in computer science. But not only that these binary operations are used in computer science, but yeah, you guys in computer science, you're going to learn that these ones here, they are good because in computer programming, it's only zeros and ones, like 1 1 1 1 1, and then 0 0 0. These are the kinds of digits that are mostly used there. And the number is written like this. And the number is written like this. Even 100 can be written differently. Even 1 million can be written in terms of the binaries. What are binary digits? You'll learn about the binary digits. Okay, I'm just mentioning these things because, yeah, we pretty much don't want to spend a lot of time on the binary digits. Okay, let's look at this one. This might be our last one because we're going to take a break and then I'm going to give you homework. And then, okay, yeah, we're going to see. Find the sum of B and C if the equation these has solutions 2 and minus 3. This one is a very interesting one. Find the sum of B and C if the equation x cubed bx equals c has solutions 2 and minus 3. What do you think?
It's
Because now the question is, find the
sum
sum
of
of B and
cubes.
C. So in other words, they're saying B and C is equal to what? Right? Find the sum of B and C if the equation x cubed plus bx equals c has solutions 2 and minus 3. The solutions 2 and minus 3 means x is 2. X is minus 3. You get the point. X is 2. X is minus 3. And then find the sum of B and C. Okay, that is too easy. Small terms
So you
equation.
say, I think maybe you'll say x cubed plus bx minus c is equals to
Yes.
2.
Yeah, the
Or
average. So if it is a solution, it means that the x equals 2 must be substituted into this. So you can put 2 cubed plus b times 2, that, because a solution is a value of x. Has solutions, these are like values of x. The solutions are 2 of them. So what is 2 to the 3? Is 8, 2b equals c. And then you substitute this one, then substitute this one, which is minus that cubed plus b into minus 3 equals c, which is minus 27 minus 3b equals c. So, okay, you get this? So find the sum of b and c. Okay, these are like simultaneous equations because you got 2b minus c equals minus 8. You can write this one, 2b minus c equals minus 8. Minus 3b minus c equals 27. Then you subtract these two things. 2b plus 3b. Okay, what is the answer here? Okay, y'all? Okay, let's divide by 5 and then you get minus 7. If you divide minus 35 by 5, you get minus 7. So once you get, yeah, getting b equals minus 7, then what is c? Can get any of these equations. Uh-huh. Okay, uh-huh. Any of these equations. Like, you can get, like the first
2b
one,
minus c.
yes, 2b minus c equals minus 8. And then you got b equals minus 7, you can put it here. Minus 7 minus c equals minus 8. Then what we're able to achieve, minus c equals minus 8 plus 14. What is minus 8 plus 14? It's like a 6. Right, so you divide by negative, you get minus 6. So if this is true, then what is b plus c? B plus c is going to be, b is what? Is minus 7. C is what? C is minus 6. And you're getting the sum of these. Okay, let's write it like a sum. Anyway, we already got the answer. So you're going to have the b. The b is minus 7. C. Minus 7 minus 6 is what? It's minus 13. Uh-huh. The answer is B. The answer is B. Any question, Neo? No question. Maybe too easy.
No question.
All right. Yeah, I'm gonna spend some time trying to practice this on these questions. Yeah, let me show one more because this is recorded. Let me see the next one. 15. Find the value of that. This one I'm gonna give as a leave as a homework. I don't like giving like lots of homeworks. So there are like too many questions, I know. But please do this one as your homework. Okay, in our next meeting, we shall do more time. Like 3 or 4 hours of a discussion on these things, we shall practice like lots.
Okay.
Because, yeah, there are many. There are
Yeah.
like up to 70. Now we're at 15. They're like up to 70 are loaded. Much more than that. Okay, but yeah, I'm just giving you these as but I can see we're at 15, but the document is so large. There are too many of the questions. But anyhow, I think that we're going to take a break right now because I planned that we're going to take like 2 hours only. And I've seen that we have gone like 2 hours in 34 minutes approximately. We started at 10. We're supposed to stop at 12. Yeah, it's enough. Sometimes you take a break. Next meeting, we're going to do like 4 hours. Okay, because they're a lot. And like practice. But not only the mathematics, but you also have literacy questions. Okay, so I'm also going to actually gather the literacy questions as well, because there's some
Or the
literacy questions.
AQL.
Yes, yes.
Yo,
So
that
maybe
one is
those.
hard, yo.
Yeah, I know, because sometimes it's a bit tricky to really get the logic and to really interpret the question correctly. Yeah,
Mm,
but yeah, I'm gonna get to those questions as well. But I'm sure that it was interesting discussing today. Right, until next time, I'll let you know when. Yeah, but you
okay.
obviously, I mean, we are sure that Saturday is our ideal day. But I mean, I
Yes,
can suggest we discuss midweek. That's the point. Whenever you're free, late hours, evening time.
yes.
Yeah,
It's fine.
we can always discuss that. Yeah, but for today, it was enough having this discussion. But yeah, try this question. It's gonna be part of the recording that I'm gonna send in this couple of minutes. Right, from us, thanks, Now it was awesome. Take care and goodbye.
Bye, sir. Thank you.
Goodbye, Goodbye, Now. Goodbye.